Welcome to Refactoring Volatile Views into Cohesive Components. My name is JEREMYSMITH. This is my avatar and handle in most places online. I'm a product-focused Rails developer. I run a hybrid, tiny one-person web studio. Someone asked me the other day, is that just freelance? Yes, it is, essentially, yeah. Although I've been doing this for 10 years, and I've realized one of the things about running a business is thinking like a business. That's kind of important. So I'm also the co-host of the Indie Rails podcast with my good friend Jess, and we just released our 36th episode earlier this week. Thank you. So we talk about independent business and Rails. We had a good time with that. And I'm going to not make this my whole personality, but last year I organized the Blue Ridge Ruby Conference in the mountains of Western North Carolina in the US. And that was one of my biggest accomplishments professionally and one of the most gratifying things I've ever done. And I guess one of the couple things I've taken out of that is how hard it is to put on a conference, how much respect I have for conference organizers, how important it is for community, and also one of the things I've realized is I love to be there at the beginning, at the birth of a conference, and so it's great to be here. So I want to talk about views today, and just to be clear, I don't mean these, or even these. I want to talk to you about these views. My entrance into web development and programming in general was through the view layer. First by learning HTML with ancient websites like WebMonkey. Does anybody know WebMonkey? Okay, a couple hands, all right. The web developer's resource. Then building web applications with tools like FileMaker Pro and its template language CDML. And then for many years working as a designer-developer, hybrid, designing layouts in Photoshop, slicing those layouts, implementing them in HTML and CSS, and then building out WordPress themes in PHP or coding custom backends in ASP Classic. I eventually found Ruby on Rails, learned what OOP was, and stretched further into the server side of things while still keeping one foot on the client side. Now, if your journey is anything like mine, starting out on the front end and moving into the back end, you might have a certain bias that I've noticed in myself. Tending to think that the view layer is easy, something sort of entry level, and that back end is all the hard stuff. But I've come to believe that that's misguided. Perhaps the view layer used to be easy, but it's far from it now. The view layer can be quite difficult, and dare I say it, volatile. Volatile, what do I mean by that? For the context of this talk, I'm going to borrow and loosely reinterpret two concepts from Michael Feathers and say that a view, and even more specifically a single UI component or element, is volatile when it reaches a high complexity and high churn. So let's consider those for a minute. Churn is a term used to talk about the frequency of change for something. This is often calculated at the file level by determining how many times the file has been changed in commit history over a certain period. When it comes to views, I think it might actually be better to consider churn at the level of the UI element, which may involve more than one file, including its markup, styling, and behavior. Complexity can be understood and measured in many different ways. My observation is that complexity in UI elements grows in three ways: accumulation, variation, and proliferation. So what do I mean? Accumulation is more attributes and responsibilities for that element. Variation, so more options or variants of particular attributes. And then proliferation, more instances of it through the system. So in other words, more things to do, more ways to do it, and more places it's used. I've also seen many dimensions of complexity playing out at the view layer. Here's my sort of exhaustive list, at least as far as I've been able to come to. Some of these are more obvious than others. Let me point out a few. Browsers and clients, this used to be a bigger deal back in the old days when we were writing CSS hacks and JS shims for everything. This is less of an issue right now, although email clients are still very difficult to work with. Some things you might not be thinking about, though. Theming and white labeling. There are some apps that you work on where, if they're multi-tenant, for example, you might allow theming for that particular user or account. Or you're building an app that will be white labeled by people that buy it to resell. Those are cases where you have more complexity because of the what you allow in terms of variance of color and style. Other things that you might be surprised to see up here, SEO and Open Graph. I don't know if you've ever heard of someone redesigning a website and their SEO tanking because of that. So there are significant issues related to SEO and Open Graph, and crawlers are users of your site. A couple others, execution context. This one has come up recently for me, thinking in terms of rendering views and whether they have access, whether they're being rendered in the context of a request response cycle or in a background job. If you're running in the background job, you don't have access to things like the current user. Another thing that has come up, and I haven't seen a good term for this, but testing affordance is the best one I've come up with. And this would be when you're running, when you're writing feature specs or system tests. And have you ever done a design change and then broken one of those? And it wasn't because that thing was gone, it was just an ID was renamed, or a class that was being referenced, the class was renamed. So thinking of those as well. So given the amount of code we have in views, the large number of responsibilities, these dimensions of complexity that I just pointed out, and the tendency for this code to change frequently over time by many team members because views are easy, often with sparse test coverage in the form of happy path integration tests, it's no wonder that the humble template struggles under the weight. It's here that I'd like to turn our attention to view components. What are view components? The way I like to think about it is that traditional views are templates that can reference any number of objects, variables, or methods. But a view component is a Ruby object that has a template representation of itself. We'll be using the view component library, which Hans gave a nice introduction to yesterday at the OSS Expo. There are other Ruby alternatives, which I'll share in the list of resources at the end. I actually care less about which library you use than that you just find a view component library to give a try to and find a solution that works well for you. All the code I'm going to share for this talk can be found in this repo. You're welcome to follow along or take a look later if you'd like. My examples are using a fairly vanilla Rails app, leaning heavily on action view helpers, along with Tailwind for CSS and Stimulus for JS. Let's take a look at a few examples. I tend to think of components falling into three different categories: utility, layout, and model specific. And I'm going to show examples of each of those. In my mind, utility components are generally components like buttons, cards, breadcrumbs, banners. These are also the components you will find in UI kits like Tailwind UI and design systems like GitHub's Primary Design System. Here we have 4 examples of an alert component. It has a color style based on alert type. It requires a message and can contain an optional title and icon. And here's the Ruby class for that alert component, or most of it. You'll see I'll sometimes use ellipses here to cut out certain parts. Looking at this, you can see the initialize takes a type and then optional title and icon. You'll notice that it renders one message. This is a slot in view component. You can think of slots as a way to name and render multiple blocks in a component. The class is constant and enforces the color styling for each alert type. And here's the template representation of that Ruby class. The tag method is an action view helper method. Other than the render call for the icon, everything else is a call to an instance variable or method on the alert object. It's pretty easy to see here that the icon and title are conditionally rendered. And then here's how to call that from the view. These are all the examples that I showed in the original visual graphic of this. Note how the message slot can be used by calling with message content in a string argument or with message in a block. Layout components are used for layout purposes. I tend to think of the layout components as a separate category from utility components because they're concerned with the layout of your elements on a page and are often invisible. And sometimes you might not even realize that they could be a component. But they often have a logic to them or a behavior that you need to take into consideration. Here are 2 instances of a layout component. Not the table and the form content. I'm talking about the invisible structure dictating that there's a header with a title and an optional parent link on the left, a main action on the right, and then the body underneath. And here's the Ruby class for that page layout component. It requires a title. It takes an optional parent link and title and link. It renders one action and one body. And then here's the template for that page layout component. In this example, I've left the CSS classes in the template itself. You can do both, or you can find your own convention for this. If you are using a utility-style CSS framework or an approach to front-end that results in a lot of HTML attributes, you'll notice that the readability of the template drops. It's certainly harder to parse if you're just trying to look at this. And here's how that page layout component is called in the view. And in particular, it's mostly not that table, but that first with action and the second, then the with body calls. And then finally, model-specific components. These I tend to think of as being tightly tied to domain concepts within the app. So in this case, this is a contact card that's tied to the contact domain model in our CRM. You could argue that these could have just been made generic card components, but if this is the only instance of this type of component, and if its design is dictated largely by the model itself, I suggest not trying to make a more generic abstraction yet. Maybe wait until you have other cases of that to create that. Here's the top half of that Ruby class for the contact card component. It accepts an instance of the contact model, and it has an inner class for the avatar component, which controls whether to display the contact's avatar or a styled circle containing the contact's first initial. Here's the bottom half of that with all the private methods. And I don't expect you to read this, but here's the corresponding 50-line template. There are opportunities to reduce duplication in this template, but I probably wouldn't on my first pass through. There is one case of nested conditional logic at the bottom, but the rest of the logic is fairly flat and readable, in my opinion. And because this template is self-contained, I feel like it's manageable on its own. And the nice thing is, here's how you call that with a collection. So you can use contact card component with collection and then pass in the contacts set of models. So now let's go through an example of how complexity grows in views and how we might refactor into components. Let's say that we're part of a dev team for an app called Volatile CRM. Product has tasked us with building a tab navigation bar for a key section of the app with links to the user's dashboard, contacts, companies, and tasks. So we start by creating a new ERB file with a nav element and 4 links inside of it. Product says this is great. They're happy with the fast turnaround time. But the designers have asked if we can have icons beside the text on each tab. We say, sure, and go back to the ERB template. We remove the first argument of each link to containing the link text and add a block with a span, 2 span tags, one for the icon and one for the text, as the color styling is slightly different between each. Product says, this looks great, but they come back later and ask if they could indicate which tab is the current one so users know which page they're on or which section they're on. They want a selected tab to have a red bottom border and bold text. So back to ERB we go. We need a div nested within the nav tag with a negative margin so that we can have the effect of a tab border with a different selection color. And we use current page helper to conditionally style the tab border and color and text weight. You can see that. Everyone's happy with this result, but not long after that, product comes back again and says, it'd be great if for some of the tabs, we could have a counter to show how many records there are. And for the task tab in particular, if we could change the color to red if there are more than 15 tasks. Okay. So we add a third span tag to 3 of the tabs, and for the task tab, we conditionally style the counter based on whether or not the account has more than 15 tasks. So everyone's pleased with this result, and users are happy, but not long after, product tells us that they're working on a new feature. They're rolling out reports, but only for accounts on the Pro plan. For accounts on the base plan, they want the tab to be disabled with a tooltip message explaining that this is a Pro plan feature only. So this time we add a check to see if the current account is on the Pro plan and generate a normal Link To tab. But if not, we render a span element that looks like a link tab with an attached stimulus controller for the tooltip. Product says this is great. Now everyone's upgraded to the Pro plan, of course, but users are having trouble discovering the app configuration options. They request a settings drop-down tab that users can click on and reveal various setting pages. But they say it should only be visible to users with the admin account role. All right. So back in our ERB template, we add a new conditional check to see if the user is an admin. And if so, we render a wrapper span that is relatively positioned with a toggle stimulus controller. Inside, we have a button tag styled like the other tabs, except that it also has a caret indicating it's a drop-down, and below this, a hidden div containing the drop-down menu links. Product is thrilled. Everything is great, but they want to add another feature to the tab nav bar. They want to add a search box to the far right of the nav bar so that users can search for anything that might relate to any of these tabs. They say this is an idea they are just testing out, so they want to hide it behind a feature flag for now. Also, they mentioned they aren't sure if this thing is going to stay a search box, but it will certainly be useful to be able to put something extra in that area to the right of the tabs. Okay. So back in our template, we add some CSS to the nav element to use flex justify between so that the search box will float to the right. And we add a new conditional block checking to see if the current account has the search feature enabled, and then render a div with our search form. And we've done it. Users are happy, designers are happy, product is happy. They even mentioned that another team is wanting to use this tab nav concept for another part of the app. And here's our entire ERB template. It's at this point that I think we're due for a refactoring. Not necessarily because of the lines of code, but because we've reached a level of volatility, for me, in terms of churn and complexity that I'm no longer comfortable with. In terms of churn, we've changed this template now 7 times. And we've grown in complexity by accumulating new attributes like icons and counters. We've added variation by things like tab type and selected state, and conditional rendering based on authorization and feature flagging. And now we've just learned that another team wants to use this tab nav in a different section of the app, so we're about to add complexity through proliferation. If others are using this pattern, they may not be as familiar with the implementation or with the constraints or requirements that we've discovered as we've been building this out. So let's refactor into ViewComponents. We'll start by creating a component just for the bar itself. This component doesn't take any arguments, but it renders many tabs. We know that. And it renders one extra area for the search box. Since we don't know if it's going to stay a search box, we'll just call it extra. And our component template looks like this. Now looking at the tab nav again, we see that there are 3 distinct types of tabs: link tabs, disabled tabs, and drop-down tabs. So back in our bar component, we're going to use ViewComponent's polymorphic slots feature to declare 3 types of tab components that can be rendered in the tab slot. I want to pause here and just say, as I was building this out, it didn't occur to me until this point that there really were 3 different types of tabs. And if I had started by extracting view components at the beginning of this, I might have tried to layer on more and more extra complexity into one single tab component rather than splitting this out into polymorphic tabs. Since there are several similarities between these 3 types of tabs, we'll create a base tab component for the shared logic that won't have its own template and won't actually be rendered, and we'll create 3 subclasses to inherit from it. So the link tab component requires a link and text with optional icon, selected state, counter, and threshold. And this is its template. The disabled tab component requires text with optional icon and tooltip. And here's its template. And this is abbreviated, but the drop-down tab component requires text with optional icon and selected state, and it renders many of the drop-down item component, which is defined here as an inner class using call for the one-liner link to instead of having a separate template just for that one line. And here's its template for the drop-down tab component. When we're finished, the entire nav bar is rendered from our views like this. We render the bar component, render component slots using with tab link, with tab disabled, and with tab dropdown. Those are the three polymorphic types for those slots. And with extra for the search box. What's left at this level is conditional logic determining what child elements components get rendered within this larger component, and the calls to the slots with those arguments. And so at this point, some people might be thinking, can't you just use partials and helpers for this? And yes, you can take that approach. In fact, I think it's actually a good intermediary step. I would suggest pushing partials as far as you can to start with. But I think there are some significant limitations if you stop there. And I think that adding ViewComponent as an abstraction layer is worth it in most cases. And so here's why. With ViewComponents, we get real class names, not just file names, to give us a common vocabulary for UI elements, both for other developers as well as designers. We have clear and enforceable interfaces with arguments and slots. We can improve clarity by extracting attributes and logic into instance methods, just like we would in any Ruby class. We have isolation from the outside view context, as view components are rendered within their own view context. That protects us from accidentally calling globals like current user or instance methods defined in a controller. And we can't even call custom helper methods without explicitly referencing them here in this class. And our templates are left more clearly expressing the document structure and remaining conditional logic. Now with partials, we're limited to using file names for naming our UI elements. We can use strict locals now in Rails partials, and if you haven't seen that, I would suggest looking that up. They allow us to specify what local variables are allowed and required with their defaults, but they're a little bit strange in this special comment. And while we can yield to a single block, we don't get multiple slots unless we use Rails capture blocks. But these also feel a little bit strange to me. And we can't enforce what gets rendered inside of those blocks like we can with component slots in ViewComponent. In ViewComponent, you can say what the slot is for, what other components can be rendered. With this, you can't. We can extract attributes and logic into methods, but we're usually doing that in helper modules, leading to helper method explosion. Since these are all in the global namespace, if we want to avoid naming collisions, we need to use pretty long method names, and we have no built-in way to know what methods can be called in what situations. For all these reasons, I would advocate using view components. So to summarize the approach I would recommend, first, implement designs and traditional templates to start. Second, watch for volatility. Is this UI element changing a lot? Is it growing in complexity via accumulation, variation, or proliferation? Third, extract your view components and regain that stability. And as you extract these view components, there are a couple things I'd recommend. First, I would write tests in proportion to your need for confidence. You can unit test view components, which is one of my favorite things. So the cost of testing is a lot less than traditional views. You can still use Capybara's helper methods matchers for this, but they are unit tested. They're not running through a request response here, like integration tests. Finally, I would use either view component previews, which are similar to mailer previews, or a tool like Lookbook to document your components and then close the loop with the design team. This allows you to sort of deliver back to them the thing that they started in terms of design. Here's the Volatile tab nav bar component in Lookbook. It has a component nav in the left panel and a preview of the component in the upper right, and then the source for it in the bottom right. If you're curious for a full side-by-side comparison of the view component and versus the partial helper solution, you can check out this Volatile CRM repository. And while you're at it, you should check out Casper Tim Hansen's exploration of an alternative approach that he threw in here as a PR. It's pretty cool. And if you like the idea of componentization, but ViewComponent isn't for you for one reason or another, these are all the other ViewComponent or adjacent libraries that I know of, and so I'd suggest taking a look at one of these. In particular, I'm quite interested in looking at Flex. I haven't used it on a project yet, but I hope to. And if you're interested, I've also collected a bunch of recommended resources that were immensely helpful to me in working on this. You can find them on my slides on Speaker Deck or using this QR code. And now just a word of thanks. I want to thank Casper for his feedback on an early version of this talk. And I want to thank the organizers of this conference for allowing me to be here. It's been great. And thank you to all of you for letting me talk about ViewComponents.
Thank you.